Welcome to Mission Control. I am stepping in as your exam flight director today for this explainer, and we are going to navigate the incredibly turbulent skies of Cambridge Mathematics Syllabus 9709. Specifically, we are locking our telemetry radar right onto topic 3.9, the square roots of complex numbers. Now listen, I want you to start treating your exam paper exactly like a highly complex flight system. It requires perfect execution, it requires systematic checks, and it demands absolute mathematical precision. If you've ever been sitting there in an exam and you felt like your mathematical proofs are just losing altitude halfway down the page, well, you are in the exact right place. We are going to stabilize your trajectory right now. Okay, let's dive right into the central question on our main console screen and reveal exactly what the principal examiners are hunting for when they grade your paper. The objective here is a multi-part past paper question. In our exam simulations, we constantly monitor the approach trajectories of two types of candidates. Let's call our first candidate Pilot Alex and our second candidate Pilot Sam. Now, Pilot Alex is incredibly smart, but he constantly overcomplicates his data calculations. He burns through way too much time and mental fuel on a single square root extraction. On the other hand, we have Pilot Sam. Sam just rushes right in, completely ignores the structural boundary constraints of the complex plane, and frankly, risks a catastrophic systemic breakdown of the whole equation. So, what separates the A-star candidate from Alex and Sam? It's the absolute mastery of the hidden parameters.
Here is our flight path for today's explainer. First, we'll break down the core principles. Second, we'll map out your procedural framework. Third, we will dodge the debris field of examiner warnings. And finally, we'll master evaluative thinking.
Section 1. Core Principles. Let's initiate our pre-launch telemetry by looking at the foundational cognitive blueprint you need for this topic.
Now, what's really interesting here is that you absolutely cannot just memorize your way through the square roots of complex numbers. The academic benchmarks from Cambridge require highly logical, structured reasoning. These assessment objectives explicitly target three distinct cognitive domains. Knowledge is just the basics, right? Knowing that I squared equals -1. Application is taking that knowledge and setting up the foundational equation, which is setting x plus iy all squared equal to a plus ib. But analysis, that is your true navigation system. Analysis is actively deconstructing the real and imaginary parts into a system of simultaneous equations to actually find those unknown variables.
So, the crucial point we are tracking on our high-tech UI console overlay is that Cambridge's assessment framework prioritizes deep structural analysis over a superficial, broad understanding. If you only have superficial breadths, if you are just skimming the surface like our Pilot Sam, you are going to hit a wall fast. For example, failing to realize that squaring the complex number x plus iy yields x squared minus y squared for the real part, that is a classic surface-level error. You absolutely must have that analytical depth to safely navigate the airspace when the question suddenly introduces unknown variables, or when it combines the square root calculation with a complex Argonne diagram problem.
Section 2, Procedural Framework. Let's examine how this builds into your actual exam strategy. This is your method mark strategy, where marks are actually awarded for your procedural execution. You see, the examiners aren't just looking at your final landing, they are tracking your entire approach trajectory. If you crash at the very end but your procedure was flawless, you can still secure critical method marks. And this slide brilliantly illustrates the mandatory 5-step standardized sequence for systematic processing. Think of this as your absolute non-negotiable pre-flight checklist for every single complex numbers question. When Pilot Alex looks at the UI console overlay of an exam question, he panics at the command keywords. But if you treat those keywords as system parameters, it clears your orbit entirely. Step 1, identify the given information. What exactly is the target complex number? Steps 2, apply the relevant principles. Set up your x plus iy squared equation. Step 3 is the most critical, execute the analysis. This means explicitly expanding that binomial and carefully equating the real and imaginary coefficients to form your simultaneous equations. Step 4, verify. Ask yourself, do my signs actually make mathematical sense here? And step 5, present your results. Format the final roots clearly. Never, ever skip a step on this checklist. Now, imagine you are mid-paragraph in a dense algebraic expansion, and suddenly you encounter a critical roadblock. Your evidence links just fail. If your trajectory starts to wobble, I am overriding the console right now to inject the Peel structural template to save your flight path. In our math context, we adapt Peel to this core loop: parameters, equations, evaluate, and link. First, you deconstruct the parameters of the complex number. Then you solve the simultaneous equations as your evidence. Finally, you evaluate the reasonableness of those roots and logically link them back to the final required format. We are taking a quick pause in our simulation right here. Before we fire the secondary boosters to secure those maximum marks, you need to optimize your flight path. Subscribe to Ace the Exams at the handle @AceTheExams right now and turn on all notifications so you are perfectly calibrated for every single mission update. Section 3. Examiner Warnings. We are now officially entering the debris field, looking at the critical roadblocks that cause systemic breakdowns. The principal examiner reports have identified exactly 3 major pitfalls that candidates consistently fall into when dealing with the square roots of complex numbers. To tackle this, we are launching an interactive viewer radar challenge. Simulation 1. Imagine a highly complex source data block on your screen right now, with a 60-second visual countdown clock ticking down. Your mission is to locate the hidden core variable. It's intense, right? That is exactly how you need to approach spotting errors in your own work before the examiner does.
Moving to Simulation 2, Debris Detection. Scan this table carefully. Your objective is to identify the specific sentence where a sample student answer falls below compliance standards. Here are the 3 categories. First up is approach. A classic trap in complex numbers is using the polar form when the context clearly demands Cartesian or vice versa. If you pick the wrong one, your whole system fails. The second category is presentation. This is where candidates do all the hard work but forget to format their final answer as a distinct set of roots, usually separated by a plus-minus sign. And third is specificity. If the question asks for roots in a specific quadrant based on a given argument, and you just provide both roots without filtering your answers, you fail the compliance standards.
Listen up, we have an active examiner alert popping up on the radar right now. You absolutely must lock down your vocabulary and clearly define your terms to avoid a systemic breakdown. When you're writing out your proof, if you're introducing variables like x and y to represent the real and imaginary parts of the square root, you have to state that explicitly. Don't just start writing equations out of nowhere. The examiners cannot and will not assume what your variables mean. Define your parameters to clear the system. Section 4. Evaluative Thinking. For our final approach, we are shifting focus to the highest order assessment objectives. This is exactly where you transition from a basic pilot to a master systems engineer. This is what top-scoring candidates do effortlessly. They don't just blindly calculate. They evaluate alternatives and provide justified recommendations. In the context of square roots of complex numbers, evaluative thinking might mean looking at your 2 resulting roots, pulling up a mental Argand diagram, and graphically checking them in your head to ensure they are exactly 180 degrees apart, exactly as they mathematically should be. It means clearly justifying why you discarded a negative value during your simultaneous equations, noting that a squared real number must be positive. You are constantly verifying the integrity of your flight path. As we confirm a successful full-mark touchdown sequence for Pilot Alex and Pilot Sam, I want you to leave this simulation asking yourself this final, provocative question. Are you actually defining your terms before you write, or are you just flying completely blind? Mastering this syllabus is all about running that pre-flight question scan checklist every single time. Remember the loop. Deconstruct, solve, evaluate. To make sure you keep passing these simulations and getting those top grades, subscribe to Ace the Exams at the handle @AceTheExams, enable that notification bell, and drop a comment below sharing your specific subject and tier. Mission accomplished, flight crew. I'll see you in the next one.